This video covers Section 8.2, Relations, Objective 2, find the domain and the range of a relation. In a relation, we say that y depends on x, and can write the relation as a set of ordered pairs, x comma y. We can think of the set of x as the inputs of the relation, and the set of all y's, y values, can be thought of as the outputs of the relation. We think of putting in Indiana and out coming the senator Dan Coates. In Washington, out comes the senator Maria Cantwell. We use this interpretation of the relation to define the domain and range. We say the domain is the set of all your inputs, and the range is the set of your outputs. So we just take all those inputs and we write them in a set. And remember, when we say set, we have these curly braces to denote set notation. So we say that Indiana is in the domain, Washington is in the domain, North Carolina is in the domain, Illinois, and Maine are all the elements in the domain. And the range consists of Dan Coates, Maria Cantwell, Kay Hagan, Dick Durbin, Mark, Kirk, and Susan Collins. And that's our domain and range. If the relation is written as a set of ordered pairs, remember it's the x values that make up your domain and the y values which make up your range. So I encourage you to take an attempt at this to state your domain and your range. Press pause on your video and come back when you want to see the solution worked out. And now that you've had a chance to work this out, the domain is going to be -2, -9, -3, and 5. -9 is the smallest one, -3 is the next smallest, and then -9, and then 5. The range, we've got 3, 4, and 9. We don't list any element twice like I did in the first one. -9, -3, and then -2, and then 5. Practice 2 is for you to also try. Think of this as a set of ordered pairs. State all of your x values, and then state all of your y values. Please press pause on your video and come back when you're ready to see the solution and press play again. Now that you've had a chance to work this out, I see that I have a point here, -2, 0. I see I have another point, -1, comma 2, and -1, comma -2. I have another point, 2, comma 3, 3, comma 0, and 4, comma -3. Stating the domain elements, -2, -1, 2, 3, and 4. And the range elements. The smallest of those is down here at -3. Then we have a -2, a 0, a 2, and a 3. And that's the domain and range of that relation defined by a graph. In these examples, we say that the domain and range are finite because you can count up the number of elements in them. For example, the domain here has 1, 2, 3, 4, 5 elements, and the range here has 1, 2, 3, 4, 5 elements. We can have domain and ranges that have infinite amounts of elements in them as well. And that's what happens when you look at a graph where we've connected all the dots. To determine the domain and range of this relation, we can't list the set of ordered pairs here, but we can imagine that if we were to list them -2, 0, -1, comma 1.3, 0, 2 point, or 1.8, 1, 2, and so on, we can imagine now that the domain has to start over at -2 and end over at 4. So what I try to do with this is contain it inside of a box. And the domain is always the set of x values. So they start over here at -2, and they go over here to 4. So in this case, we don't list them. We write them in either interval notation or with an inequality. Interval notation would go from -2 to 4. Or we could say that x is greater than or equal to -2 and less than or equal to 4. The range is the bottom of the box to the top of the box. The bottom of the box starts off at -2 and goes to the top at 2. So in interval notation, we go from -2 to 2. And in this case, in inequality notation, we would say that y is greater than or equal to the lowest number, -2, and less than or equal to 2. Those are infinite domains because there's an infinite amount of numbers in those sets. Sometimes you can have graphs like parabolas that continue their y values all the way on up to pos infinity and get an infinite domain that way. And this leads me to your practice problem, practice 3, determine the domain and range of this relation. I encourage you to press pause on your video and work it out and come back when you want to see the solution. Now that you've had a chance to work this out, I will work this out with you. So we try to enclose this graph with a rectangle. The left side of the rectangle looks like it's at -5, and the right side looks like it's at 3. So the domain consists of all the numbers in between -5 and 3. Everything to the right of -5 and to the left of 3. Domain is always x values. Range is always y values. We see the y values get down as low as a -1 and up as high as a 3. So in interval notation, we always state the smaller number first and then the larger. And this would say that y is greater than or equal to -1 and less than or equal to 3. And this concludes the video for section 8.2 relations. Objective 2, find the domain and the range of a relation.